I warned you years ago that teaching sand to think was a mistake. We literally sell the t-shirt. This is the Gigabyte AI Top, your personal supercomputer. This is DGX Spark, but this is Gigabyte's version. I first saw this at Supercompute 25, and I got some anomalous results from this, and so I said, hey, Gigabyte, can I borrow that? Can I run some tests? I have some very surprising results to share with you. This is the DGX Spark platform. I've done a number of videos on the DGX Spark from different vendors. This is Gigabyte's version, but it's special and it's a standout, and they've done some things. They've made some decisions, not just their software bundle, which is also different. They built their own AI Top software for this platform to make it a little easier. I want to show you. Let's unbox, see what you get, and go from there. This has been reboxed a few times, so you have to look over me. All right. Again, NVIDIA controls a lot of the functionality here. It is the same physical layout. I mean, you've got the same 4 USB-C ports. One of those is for power. I have not been able to get pass-through power working with this 4th port, just FYI. So like with laptops, you have these really amazing little USB-C hubs that you can plug in, and it'll split out the power delivery and USB-C function. I have pass-through hubs that support up to 240 watts, but it does not work with this platform. The other 3 USB-C ports are 20 gigabit, which is nice. HDMI, which is also very amazing. 10 gigabit, provided by a Realtek chipset. Our ConnectX 7 NIC, which is part of the price of admission to this platform. And then we have the device itself. There's a Kensington lock port on the side. I always forget to mention the lock port, but you know, they're for like lab managers that are deploying these in university labs. The Kensington lock port is kind of important, especially when it's something that's this small and this pricey. The design is similar. This is a magnetic door on the bottom. It's got nice little rubber feet. It's got a Gigabyte aesthetic. They didn't go for the ostentatious gold, but internally, they've made some pretty significant upgrades. One of them is a vapor chamber cooler, which will be important in just a second. All right, in the box, you get a Delta power supply. This is 240 watt USB PD 3.1, 240 watt. Now, NVIDIA, when DGX Spark first launched, John Carmack, famous programmer and smart person, got a DGX Spark, and he immediately had thermal and overheating problems. With the one that I got from NVIDIA, it would definitely throttle back when I was using the ConnectX 7 at full performance and the CPU and everything else, but I was doing some off-label stuff. The easiest scenario to get it to throttle in was gaming. Gaming? What? It's an ARM platform. You can run something called Box 64. You can deploy your Steam games. We'll have some fun with that in a little bit. It's not meant to be a gaming platform, but boy howdy, it sure can game. It's an interesting sort of synergy. It's interesting for developers that are working on games, I'm sure, a little outside the AI wheelhouse, and also maybe a portent of, a bit of a warning, a canary in the coal mine for x86 gaming, self-contained. Once we get past this DRAM drought we find ourselves in. But this is about AI. This is about 1 petaflop of NVFP4. This is about raw compute performance and CUDA cores and the ConnectX 7 NIC. You buy into this platform because you are a developer that is working in the NVIDIA ecosystem, or you are a developer looking to learn more, or you're a developer looking to construct something that requires 128 gigabytes of VRAM. Now, it is LPDDR5, 273 gigabytes per second, and so the inferencing performance will be limited by that. But smaller models, you can fine-tune the CUDA core. The sheer number of CUDA cores on this makes things like image fine-tuning fun and possible. So tell me a little bit more about the ConnectX 7 networking. This is a really important thing to understand as part of this platform. If you get a ConnectX 7 NIC separately, you're going to be spending north of $1,000 just for the NIC. The ConnectX 7, part of the story of AI and the growth and expansion of AI, has to do with expanding models that are simply never going to fit on a single GPU or even a single server. And so what has happened is a lot of development has happened around the fabric. And the fabric really sort of generically refers to a networking topology that gives you RDMA over converged Ethernet that lets one GPU and one system access another GPU and another system as fast as possible. Typically 800 gigabit in the deployments that are happening today with 1.6 terabit not too far over the horizon because we're on a yearly release product cadence. The ConnectX 7 NICs in the Spark, technically speaking, they're 200 gigabit, but the internal topology of the NIC means that you will see two 100 gig links on either side of the MediaTek ARM processor. See, it's 10 fast cores and 10 slower ARM cores. It's 20 cores. I mean, it's nothing to sneeze at. It's a ton of performance. My experience just cobbling things together has been that the best performance comes from using both NICs at roughly 100 gigabit, give or take, assuming that you're not entering thermal throttling territory or anything like that, or the system is not otherwise power constrained with whatever else you're running on the system. You can do 200 gigabit over a single QSFP connection, but it's going to be relegated to just RDMA and just nickel in CCL. This is a whole other rabbit hole you can go down in terms of building and configuring applications. For my testing, I built my own Python program to test the nickel libraries, and there is a little bit of overhead with that, and there's also fine-tuning that has to be done with that because you're typically are working better in batch sizes of like a megabyte or more. If you have very small batch sizes, the latency will eat into your maximum throughput because you're waiting on that round trip time, and you're not really taking full advantage of the bandwidth. If you're doing this on the TCP side of things, you're going to be sorely disappointed because if you're just doing an Ethernet TCP, no RDMA type connection, you're going to quickly swamp the CPUs because it's a lot of CPU overhead to deal with that. You really want RDMA. And the latency and the performance numbers for that, not great. So if we side by side those two numbers, RDMA and pure Ethernet, we see that RDMA is much better. And it is, pure Ethernet is like iPerf3. Even iPerf3 with like 8 parallel. Yeah, I mean, you can achieve 120 gigabit, but 200 gigabit is just not happening with the cores in Spark unless you are going RDMA. And if you're going RDMA, it's basically no CPU overhead. It's like 2 to 3% CPU overhead. And so this is a thing you discover as you work on this if you're onboarding into the system, but that you can discover that on such a relatively small $4,000 US at the time that I'm doing this video system is still very impressive because this is the kind of thing that you run up against when you're working on multi-million-dollar systems. It also means that you can connect multiple Sparks together. Now, officially, NVIDIA only supports 2 Sparks at the time that I'm doing this video. I have a feeling they're going to make an announcement about this because a lot of hobbyists and randos like me have like, 2, I can go more than 2. So check out this. I've got our MikroTik platform set up here. I've got 4 Sparks. We've got the NVIDIA Spark, which has been repasted and has been doing a lot better with its new paste. I've got our 2 Dell Sparks, and then I've got our Gigabyte Spark connected here. And our Gigabyte is the fastest of the bunch here. In fact, I think it is the fastest Spark that I've tested so far. They've really just thrown the power constraints, the recommended power constraints to the side from NVIDIA, and or that vapor chamber cooler is really doing some heavy lifting here. Literally, slightly more than 10% faster than the reference design from NVIDIA, which is pretty darn impressive. Nice job, Gigabyte team. But that networking platform here gives us a 200 gigabit interconnect. And so I have 512 gigabytes of memory on this platform. Now, I have to mention Macs. I don't have Mac Pro, and I typically have not really even given Apple the time of day because of past sins and transgressions and things like that. With the memory wasteland that we find ourselves in, the 256 gig and 512 gig Mac Pros can be an alternative that makes sense here. I mean, those are $10,000 machines, and this is a $4,000 machine, but like Jeff Geerling has done a lot of excellent videos doing those types of comparisons, and you can really crunch the numbers. And my only caution with that, and this is not a caution from Jeff Geerling's content, he's very good, but in general is like there's a hyper focus in some user communities on just inferencing performance, just running models. If you're just interested in running models, there's probably something else you could do out there that would make more sense for what you want to do. But if you want to do fine tuning or go down the rabbit hole with nickel, as I have, like I've had a lot of fun, just the curiosity of like, how does this work? And even though I can lay hands on like some GB200 systems that are, out there, they're so expensive. I am scared to death to, it's like, it'll be fine. Let's just run some experiments and do this for taking down a legitimate job while I'm just stumbling around doing, fun, interesting stuff. Even a single chassis, 8 RTX 6000 chassis makes me nervous because it's like, that machine is not idle. Somebody is losing money if that machine is not idle because of the sheer expense of it. And I, a rando, it's like, oh, let's run this. Like, can I learn this? It's like, oh, there's been a breakthrough in transformer architecture or whatever. And it's just like, I just want to learn and have fun with that. And so I can do that with these, even though the inferencing performance is something everybody is hyper focused on. I think they're kind of, it's kind of a can't see the forest for the trees kind of situation if that is your focus, because I've even gone off the deep end. I'm connecting this thing to an RTX Pro 6000 workstation, but that's going to be a different video through, the Connect X7 and RDMA. So like I can do this and I can do the other thing. The XO project will let you connect a whole bunch of Macs together through Thunderbolt. That's really exciting. But these darn things are so fast, you can use this as a front end for prompt processing and prompt decode, and then feed that to the Mac cluster, which is insane. And I think also is, another data point for me to say that, well, this thing is pretty legit in terms of computational horsepower. You should probably look at that, given that you're, using one of these to augment another, DIY randos cluster, actually does make a big difference in terms of performance and everything else. So I've been having a lot of fun with that. All right. So I've got 4 Sparks set up on my workstation behind me, and our Gigabyte AI top is in the lower right-hand corner. Now, when you unbox one of these and set one of these up, it's designed to be productive from the get-go. You can use it as a desktop computer. I mean, I've basically hooked it up to a monitor, keyboard, and mouse. You can use it that way. You don't have to hook it up to a monitor, keyboard, and mouse. You can plug it into your network, and you can literally download client software for Mac OS or Windows, and I think also Linux, that will scan the network and find it, and then you can just SSH into it, configure it, and do everything from the web. So it can be an appliance. The Dells even have like a Wi-Fi network built in, so they'll broadcast and you can set them up completely wirelessly or boot from the network or whatever. And just like other Sparks, out of the box, it does have the Wi-Fi option. So you don't even necessarily have to connect it to a wired network at all. You can connect to it wirelessly and configure it and then put it on your own wireless network. It's its own hotspot out of the box. And then once you configure it, you're connected. But really, it's got that built-in 10 gigabit wired Ethernet. You should definitely use that. Spark is really designed, that's an NVIDIA imperative. Now, it's DGX OS, but that is based on Ubuntu. But it is the full fat Ubuntu. So like you can do, Canonical has pro support and long-term support and things like that. And NVIDIA has been known not to have the longest support life cycle for some of their products, and people were starting to notice that, and so they're taking a different approach here. I think that this, I'll probably end up eating my words. I might end up eating my words, but it looks like with the pro support Canonical thing that NVIDIA is leaning on these being in the ecosystem for a long, long time, as opposed to some of their other stuff. Now, one of the things that sets the Gigabyte apart is the AI top software, which we'll talk about in a second. But if you're just watching this and you're just getting clued into the Spark ecosystem, you've got to check out build.nvidia.com/Spark. All of the stuff that I learned and put together for this video came from there, basically. That's what I started out with. That's what I'm learning from. And that is what is incredibly exciting about it. It's like, oh, there's good documentation and it's well put together. And it's a paint by numbers, full soup to nuts recipe for everything, including setting up multiple systems. If you have 2 of these, you can use a single crossover cable. I'll talk about multi-Spark in a minute. That should be its own, chapter bookmark in the video. But the software experience out of the box here, build.nvidia.com/Spark. You can set up your code editor and have it talk to this thing for AI code assistance or whatever. Download an open source model and get it up and running. You have 128 gigs of memory to work with here. If you're running a dense model like a GPT OSS 20 billion parameters, those kinds of models are generally in like the 10 to 15 token per second range. Mixture of experts models where you might have, a 40 billion parameter model, but only 6 or 8 billion parameters are active at any given time. You might get upwards of 25, 30 tokens per second on this. Really, that's inferencing speed, and that is dominated by the memory speed, which is 275 gigabytes per second. And there's tons of resources online like that. That is covered everywhere on the internet when you're doing research for these things. Image inferencing and fine tuning, there are build.nvidia.com walkthroughs for that. If you want to go beyond setting up your editor and go for like the full multi-agent thing, I would strongly suggest that you take a look at the vision language models, which we looked at with the Jetson, Thor, and Nano families, which will also run on this. It's a collection of agents that can run, and it's like, oh, it's a vision. It can process vision. And so you can capture from a webcam or an IP camera or an RTS MP stream, and then do analysis on what it sees in the stream and give you commentary on that. When you graduate from that, there's also video search and summarization. And understand that with video search and summarization, there are multiple AIs running in the background. It's not one monolithic AI. You have an AI that is supervising the video, another AI that is flagging events, and then that can be presented in a web GUI. This is a full soup to nuts demo that has everything you need to set up and do that kind of thing. And that brings us to Gigabyte software. What does Gigabyte do to augment that's provided by NVIDIA on every Spark? Well, they give you a web GUI to automate some of those things. The AI top dashboard by default gives you a view of the system, how busy it is, how much memory is being used. This is not a lot different than what we see on NVIDIA's out-of-the-box configuration, but Gigabyte's put some work into theming that. But that's where the similarities end. There's an inference tab on the left. Now, from my other videos, you know that you can set up Jupyter notebooks, and that's something available out of the box in Spark. This is no different. You can do it that way. But if you're going to use Gigabyte's AI top utility, they make it a little easier to find the type of model that you want. So you can do text recognition or, image mapping, segment anything type of thing. Segment anything is from Meta, but there's Nano Sam, I think, from NVIDIA. They've done some Herculean things in order to make that run well and fast on this platform. And so this is going to do the right thing and create a Python virtual environment for you. And this is a fun little piece of software to play around with that differentiates Gigabyte from some of the others, especially if you're starting from nothing. It is kind of fun to play with. There are some bugs. I encountered some bugs setting it up and doing some different stuff with the model. Well, the model directories for like text to image and setting up some things like that. But it does generally make your life easier if you are starting from scratch. But it's definitely helpful if you know Python and you're getting yourself into some fairly complicated stuff. So you shouldn't be that much of a noob, but a little bit of noobishness maybe is okay. Now, multi-networking, NCCL, nickel, it's a lot of fun. To get this thing up and running at 200 gigabit, all you need is a QSFP 200 gigabit cable, which Gigabyte sells for about $50, give or take. You only need one to connect two Sparks. ConnectX-7 NIC on the back, it has two 200 gigabit ports. But understand that the ConnectX-7 NIC in the Spark is fairly sensitive to thermals and is implemented with PCI Express by 8, and the implementation is a little unusual. And so there's been some confusion in the community and some confusion on my part as well. Like, it's like these things are released and they don't really like talk about the nuts and bolts here. They're just like, oh yeah, it's 2x 200 gig. There's an asterisk there. There's a gotcha in NVIDIA's implementation. The first gotcha is the thermals. Like, does the Spark implementation give you enough thermal headroom? Hey, it launched a Jupyter notebook. That's awesome. Does it give you enough thermal headroom in order to do what you want? And then the second part is, how are you using the NIC? RDMA over converged Ethernet, ROCE, versus just, straight IP, iPerf. Those are all going to be very different things in terms of performance. And the thing that I knew but didn't realize is which thing is generating the traffic. Even with an RDMA scenario, is the GPU generating the traffic or the CPU generating the traffic? So in an ideal best case scenario, yes, with these Sparks that have better cooling, like the one from Gigabyte, I am able to achieve 200 gigabit off of a single cable, and that is mind-blowing, but only in RDMA, and only with like nickel tests, and only with the relatively larger windows for nickel tests. The other thing is that a lot of the technology here is borrowed from InfiniBand, and a lot of the old InfiniBand commands still work. And so if you're coming from an InfiniBand world, and I was a little bit more familiar with the InfiniBand side of things, I was using InfiniBand write bandwidth as like a test and a diagnostic. And with some of those tools, you might only see 108 or 110 or maximum 150 gigabit. And so that's a little different problem. And if you're over on the CPU side, remember you've got 10 fast ARM cores and 10 slower ARM cores. anything that is CPU limited on the TCP side of things, even if you're running 4 or 8 or more threads, you're not really going to saturate the 200 gig link. But because the way that the ConnectX-7 NIC is set up with the 8 lanes, you can have, like, each QSFP port is connected to both halves of the NIC. And both halves of the NIC can speak at 100 gigabit. And so you can have one physical port that's getting 100 gigabits of information from 2 different sides. Patrick at Serve the Home did a diagram for this that is fantastic and way better than I could explain, because I was just like, oh, this is obviously like a PCIe resource contention issue. But NVIDIA did some stuff in ConnectX-7 because you can move one thing over to the other. And this is actually a really interesting thing in systems at scale, and it has to do with NUMA nodes, because you can have an X16 ConnectX NIC in like a big giant server system where 8 lanes on the NIC connect to one CPU socket and 8 lanes on the other half of the network card connect to the other CPU socket. So you have this network card that's connected to 2 CPU sockets, and some of the remnants and gotchas of that, which is a very real problem, it carried over to this little tiny platform, which is amazing. And that means that it's really good for learning and all that kind of stuff. But that's a lot of words to just basically say, if you get 2 of these, you only need 1 cable to run at 200 gigabit. In the best ideal scenario, RDMA, yes, 200 gigabit is achievable. If you're having thermal problems, it'll back off. But the power utilization for this thing, running full tilt, I'm seeing just over 200 watts, right around 200 watts, which again is our best case scenario. And the performance numbers that it posts are fantastic for inferencing and for fine tuning and all of the benchmark stuff that I was able to come up with. So that's great. I've got another video, if you're in the whole, there's another video on dual sparks, and that applies here as well. But the setup that you see on my table here is 4 sparks. And 4 sparks are connected to that DDQ switch from MikroTik. And that is 4 QSFP ports on that thing, 2 that are 400 gig and 2 that are 200 gigabit. And the ports on those, even though it's 200 gigabit, is not the same 200 gigabit as this, because this is really 2x 100 gigabit, which the MikroTik switch doesn't do. Like, that's a whole other level of complication. Like, NVIDIA kind of did their own thing with the 200 gig side of things on ConnectX-7. And there's another different thing to worry about. And that is going to be a different video. So if you want to learn more about that, or stay tuned for that, or see what I discovered there, stay tuned for that, because that's going to be a separate video. But know that you can run 4 sparks with nickel, and MPI run works fine in that scenario, and you get RDMA in that scenario with your DDQ MikroTik switch at 4 times 100 gigabits with 400 gig interfaces. You can also do 3 sparks with no switch, because you've got 2 ports on the ConnectX-7. Every spark connects to every other spark. That is also doable, but the networking there is way more complicated than just plugging in this, because you don't have a direct path to each one, and you have to take that into account. And like MPI run using X to just forward environment variables between machines is not going to work in that 3 spark scenario. It's going to need a little bit more plumbing. But 4 sparks and a DDQ switch from MikroTik with RDMA, yeah, that part works fine, which is fantastic. And so multi-spark experimentation. But the thing that blows my mind is that this really is applicable to stuff that I've run into at very large deployments and very large scale, and even going off roadmap and doing things like mixing ConnectX NICs with AMD compute resources and building your own fabric based on stuff like that. And it's like, wait a minute, how are we going to do this? But that's, again, stories for another day. Gigabyte is doing awesome here with the thermal and power constraints is your takeaway. And running multiple sparks is also a whole dimension of learning that is available to you. That is, you can do plug and play, but you can also do performance optimization and get better performance out of it. So bottom line, when you look at this with the 100 gig interface through the MikroTik, it's 100 gigabits, 10 gigabytes-ish per second. And if you look at the table, the performance numbers from the nickel benchmarks, you can see that it takes a lot longer to ramp up to that size. And that's because of the added latency. You're going through a switch as opposed to direct connect. Like, that's a huge latency savings more than a bandwidth savings. But these cables do link up at 200 gigabit, and in that nickel sort of cross chassis configuration in the nickel benchmark, you can see 200 gigabit. In my own test Python program that uses the nickel libraries to just shove information onto the fabric as quickly as possible, even with, I think it's 128 meg buffer sizes, it was still tough for me to achieve the full bandwidth there, something in like the 120 to 150 gigabit range, but it's still pretty respectable and still pretty good performance overall. So it can deliver. But connected through the switch, it takes a lot longer to get up to that 10 gigabytes per second or 100 gigabit because of the added latency, I suspect. So that's the difference in those two tables of numbers. I was experimenting with NCCL algorithms as well, like tree versus ring, and this I thought was really funny. There's output in the logs that says NCCL info connected all trees. And then I thought of this. It's really cool that I can use this setup, this contraption to show you what's inside my brain. But enough of that. So with our 4-spark configuration connected through doing the nickel test, this is just using NPerf, by the way. Yeah, you might want to stick to the ring algorithm. Average bus bandwidth, 9.48 gigabytes per second. Yeah, it takes a little bit of time to ramp, but that is dramatically better than the 2.49 gigabytes per second we got from the tree algorithm. I guess that makes sense. You don't want lumberjacks plugging in your trees. Oh, and in case you're wondering about the same test with just the crossover cable only, no switch involved with the 200 gigabit link. Yeah, I mean, without doing any tuning, 10.65 gigabytes per second. But we can do tuning, and we can actually hit 20 gigabytes per second. Now, I mentioned the InfiniBand leftovers. Yeah, the InfiniBand leftovers sometimes butt you in the butt. I was debugging nickel in my own Python program, and it seemed like the IB GID index of 3, which is a V2 device, was what I wanted to use, but that's not actually the fastest one. And also leaving it unset was limiting performance. But if I explicitly set it to 0, it's even faster versus device ID or the GID 3. I'm not sure why that is. It's definitely still using RDMA, and I even use the environment variable to disable IP fallback, because like if nickel can't do something, it'll do IP fallback, and then you know something has gone wrong because your CPU utilization is really high. I didn't do that. So there's the environment variables I used, and with those environment variables, except for the GID is 0 instead of 3, it's 3 in the screenshot. 0, look, 20 gigabytes a second, 200 gigabit, one cable, magic. Can't do that through the MikroTik, but you can do it with the crossover cable. It's pretty good. So there you go. There's the Gigabyte AI top. Solid engineering. This is probably some of the best engineering from Gigabyte that we have seen from Gigabyte. And they're the champs here, I think, with the DGX Spark launch and the performance. And the software that they did, it's neat. It's fun. It makes it a little more accessible. I think that it's a little bit of a miss that they don't offer downloads on their website for that. Like if you have to re-image this, you're getting NVIDIA's image for this. And so Gigabyte should have an image of this device on their website to download, or at least steps to deploy their package and configuration should you need to re-image this. Like all the other DGX Sparks, it's 2240 M.2 internally. I asked why. Why is it 2240 instead of a 2280? Apparently an oddball design requirement from NVIDIA. I get the feeling that everybody pushed back on that, and everybody sane should push back on that, because there's physically room for a 2280. The heatsink's in the way, but 2280 would have been fine. You could have used a taller M.2. The thing could have been 3 millimeters taller with more plastic on the bottom. Don't make me 3D print adapters, because you know I will. But that's an NVIDIA thing. That's not a Gigabyte thing. Gigabyte did an amazing job putting this whole thing together. I'm Wireless Level 1. If you have a job you want to run on these, like you don't have one of these and you want to play with it, hit me up in the forum, because I've been doing that and we've been turning it into videos where we can. So yeah, if you want to try to run something, a job, see how it performs, do some fine tuning, do some experimentation, I've been doing some of my own stuff. I accidentally trained a model to, whenever it needs a person, it's putting in a famous Hollywood actor. But then it also started replacing animals with the famous Hollywood actor. So I feel like I probably didn't label my data set correctly. Anyway, I'm Wireless Level 1. I'm signing out. You can find me in the Level 1 forums. Let's have some fun. All right. Signing out. I'll see you there.